distinguished guests, students, parents, principals, teachers, warmly welcome you to this seminar. I see a number of international faces, so that's the reason we will conduct this seminar mainly in English. Sometimes I will repeat those professional terms in Chinese, in Mandarin or Cantonese. Okay, so I hope in today's session here, you will get the chance to know what's going on outside the space. So I will talk about the moon exploration, especially we go to the lunar South Pole, and we use robotics to help us to explore and to establish future outposts or future research stations over there. So I would like to start my talk from here. I like hiking very much. So sometimes I spend a half day climb on a mountain. I sit somewhere on the mountain, then when it reaches to the late afternoon of the day, I get a chance look at the sky, look into the deep space. Then I see many shining stars like this. I believe most of you might also get this feeling, this experience. So when you see the sky like this, the deep space, the universe, many stars, they are shining over there. What will you think about this scenario? So will you have some questions to ask yourself or to ask your dating mommy when you are a little boy or little girl? So we want to know, where are we? Okay, in the universe, where are we? Where do we come from? And some more fundamental question here. Who are we? Are we alone in the universe? And more importantly, for the future generation, where are we heading? So all these fundamental questions, scientific questions, they need our exploration, our imagination. So space exploration basically will help us to find questions, or find answers to all these questions. So space exploration is defined by NASA from the United States, can expand our humankind understanding of the Earth and the universe. And more importantly, it can promote human civilization and social progress. So space exploration is not only explore the outer space, but can also help us to understand our own Earth and promote our human civilization. While you don't think space exploration is far away from us, actually, if you look at your mobile phone, okay, your camera phones, and your laptop, okay, the TV you are watching every day, the shoes, TV shoes you're wearing, okay, the solar cells, all right, the CT scans, and even the baby formula, okay, actually, they are coming from the space technology at the very beginning. So you can imagine the technologies developed in the space exploration actually will help us, will help our daily life to be more advanced and more convenient. That's the reason how space exploration is always exciting and inspiring. While the moon is our closest neighbor, right? Only 38,000 kilometers away from the Earth. While this is always the most popular place for different countries in the world, all right, to visit the moon. So the moon, you can see here, okay, it's about 1/4 of the size compared with the diameter of our Earth. All right? And the other parameters I listed here, and please also pay attention to one of the important parameters, which is the gravity of the moon is about 1/6 of the Earth's gravity, which means if you jump, okay, on the lunar surface, you will jump maybe 6 times higher as you do this on the Earth's surface. Okay. So the moon has been very busy during the past 20 years, and actually 60 years ago, in 1970s, the United States and the Russia, they already landed on the near side of the moon, many places, from the Apollo missions, okay, to the lunar missions from Russia. And in the recent 20 years, the Chinese missions, including Chang'e 3, Chang'e 4, Chang'e 5, and the Chang'e 6, landed on the moon as well. Particularly, the Chang'e 5 and the Chang'e 6 landed on the far side of the moon, which is the first on the history of the mankind. So let's have a brief review of these important missions, starting from this one. So I believe most of you should feel familiar with this footprint on the lunar surface, right? By the American astronaut Neil Armstrong. A small step for man, one giant leap for mankind. This is a very famous saying by the astronaut Neil Armstrong. Okay. So this already has been there for over 60 years. And also, I know there's a lot of rumor over the internet. People are thinking about, oh, this may not be true. This might be manufactured in a movie factory, etc. What I want to share with you is like this one. This is the first Chinese mission landed on the lunar surface, the Chang'e 3. So if you look at this satellite image here, actually there are 2 satellite images. One is before the Chang'e 3 landed. The other is after the landing. So you see this white dot is the land of Chang'e 3. And then here is a small dot. This is the lunar vehicle, Yu-2-1. So this basically are the images taken by cameras on board the satellite. So what I want to say here is Chang'e 3 indeed actually landed on the lunar surface, not made in the movie factory. Okay? While This is the landing spot of Chang'e 3, and this place is called Sanus Evident, a very significant landmark on the lunar surface. Sometimes in the evening, when the sky is clear, you can even use your left eye, okay, to look at the moon, and you can notice this curvature feature, okay, sinus evident. Then you can think about in the east part of this area, about 1 kilometer away from this feature, there is a lander and a robotic vehicle. They are working there. They stayed there for quite many years already. And they studied this place with very much interesting scientific findings. That's from our China's space mission. This is Chang'e 3, already 13 years ago. I still remember the time when we participated in the landing site mapping and analysis for this mission. Then, this is the mission called Chang'e 4. 2019, this lander, Chang'e 4, landed on the far side of the moon. This is the first mission landed on the far side of the moon on the human history. No any other country did this before. So you can see the Chang'e 4 landed over there, and there is another vehicle called Yu-2 be released from the lander. Okay, and this photograph is called a panoramic photograph, provide a 360-degree view of the surrounding environment of this region. Actually, this also involves the contributions from our university, PolyU. So you see here, there is a mast. This control system, just like a pole, controls the camera to rotate 360 degrees and to tilt like this way. So this facility, actually, this one was developed by PolyU. And my team also helped with the landing site analysis and the evaluation for Chang'e 4. Then, after several years later, there is another mission called Chang'e 5. So Chang'e 5 landed on the moon, on the near side this time, but with a very important achievement, which is this one. This is a soil sampling system to collect some samples on the lunar surface, soil samples, and bring them back to Earth. So this surface sampling instrument was also developed by PolyU, by Professor Ren Qiliang's team. And my team also helped the analysis of the landing site. So finally, the Chang'e 5 landed somewhere here, which also involves our contribution from PolyU. And more recently, you see here, this is the Chang'e 6, landed on the far side of the moon just 2 years ago in 2024. So similarly, you see, there is a surface sampling, soil sampling system here, okay? And the Chang'e 6 successfully used these sampling systems, brought back about 2 kilogram soil samples from the moon. And a lot of researchers, scientists in mainland, in Hong Kong, we are doing research on this as well, and the international experts. We are start these soil samples collected from the near site by Chang'e 5 and from the far side by channel 6, okay, we want to see what are the difference, okay, between the soil samples on the moon and on Earth, and what are the difference between the soil samples from the near side of the moon and from the far side of the moon. This is a real image taken by a camera. A small vehicle drive away from this lander and look back, take such a photo. So have you noticed this surface here? They are relatively loose, okay, compared with the image I showed to you on the near side of the moon. So the near side and the far side, the soil materials, the structures, they look quite different. So these are very interesting research questions. Young students in the future, if you are interested in this type of scientific research, then you probably prepare yourself, okay, such as the space technology we are discussing here today. Right? Well, then let's move to the lunar South Pole. The lunar South Pole actually will be the focus of future missions to the moon. Why? You see here, the moon has a very small tilt angle of the rotation axis with respect to the sun illumination direction. The angle is very small, about 1.5 degrees. Okay, which means the solar elevation angle at the North Pole or the South Pole is very small, about 1 to 5 degrees, for example. This is like the situation on Earth when we are in the very early morning, like 5 or 6 o'clock in the morning, or in the late afternoon. 就像是在早上的凌晨，太阳刚刚出来啊，季初的时候，或者是夜晚黄昏的时候，太阳非常低。The sun is very close to the horizon. In this case, at the polar regions, some deeper craters, you see a lot of this type of impact craters, they are formed by impacting from the meteors, okay, or asteroids. Some deep craters, they will level shine, okay, because they are deeper and the sun is very low in terms of the elevation angle. Therefore, they are in permanently shadowed regions, okay, which means all the years, all the time, no sunshine at all, 永远照不到太阳。Then the temperature in this type of craters is very low, okay, even below negative 200 degrees. Then this provides a very good place for the water, ice, to stay there stably, even for billions of years. The temperature is very low, okay? No sunshine, no radiation at all. So if there is water on the moon, these are the perfect place for water to stay there stably. While this is from the real video taken by a camera on board the satellite orbiting the moon. While if we look at the surface, on the surface of the lunar South Pole, what do you see here? Because the sun is very low, okay, close to the horizon. Then you see those rocks, those terrain fractals, these rings of mountains, they create very long shadows. which means, you see, in a picture taken by a camera, you see majority of the region is in shadow. This will be a very difficult situation for robots, even for astronauts to explore, to operate it. Okay. While, as I mentioned to you earlier, people usually believe the moon is dry. Like back to 30 years ago, 50 years ago, nobody will believe there is water on the moon. While recently, okay, a lot of remote sensing or impact experiments discovered water on the moon. So this type of water, actually, H2O, if you studied physics or chemistry in your secondary school study, then water, H2O, okay. This water can come from impacts by water-rich comets or asteroids. Okay. They hit on the lunar surface and the temperature is very low, then the water ice carried by the comets or meteoroids, they can stay on the lunar surface stably. Another type of water is called hydroxide. The chemical structure is OH, okay, with one oxygen and one hydrogen. Okay. And this type of hydroxide, actually, they come from the interaction between the solar wind, okay, with the lunar surface materials. There are a lot of hydrogen in the solar wind and a lot of oxygen, okay, in the lunar soil. So they interact each other. It will form this type of hydroxide on the lunar surface. So what you see here is on the lunar south pole, those green dots, they represent the places with potential water ice. On the north pole of the moon, similarly. So let me talk about a little bit more methods, remote sensing techniques, okay, to provide evidence of potential water ice on the lunar surface. So the most famous one is from this one. In 2010, back to over 15 years ago, there is a satellite called Aircross. This Aircross from NASA, this satellite conducted an impact experiment, okay, close to the lunar south pole. So this satellite basically released, okay, a rocket like this one from the orbit, and this rocket impact in the lunar south pole in a place called the Cabeus crater. Scientists already did a lot of research regarding this Cabeus crater. They identified potential water ice signatures from remote sensing techniques, while this impact experiment actually verified this signature by, you see, the rocket hit the Cabeus crater, then after 1 minute, a lot of debris, a lot of plant, okay, and the space above the south pole. And the instruments, spectrometers on board the satellite take a real-time observation of this debris, then identified a lot of hydrogen in this debris. So this impact experiment indeed verified the existence of what as hydrogen over there. Another technique I want to share with you, okay, is this type of technology called spectral measurement, 光谱测量. You know, the light, sunlight, illumination, every day we see this type of sunlight, right? But actually, probably you didn't notice before. So the spectral bands of the light, actually, starting from very short wavelengths. Students, if you studied physics before, then you probably already aware the light is actually a wave. Okay. So the wavelengths in different bands, for example, 1 micrometer, 10 micrometer. Okay. What our human eyes we can see, they are from the visible lights, blue, green, red, right? They are in like from 400 nanometer to about 700 nanometer, a very short band here, which is visible to our human eyes. But actually, there is a lot of other invisible bands, okay, in the solar illumination. So we can use this type of information to distinguish different objects, okay, just like fingerprints. Everybody, your fingerprints basically tells you who are you, right? This is the very unique identity of each person. So, you know, here, if we take images of different objects by using different spectral bands, then you can see different objects, different types of them, they have different spectral curves. For example, here you see water. Okay, water is here. The spectral curve is like this. From 400 nanometer wavelengths to 900 nanometer wavelengths. Water will behave like this. Well, if you look at stone, okay, stone, then it will be different. Then if you look at trees, grass, sand, the spectral curves for each type of material, they will be different. 这里就是说，不同的物质 ，different materials， 不同的材料，它们会有不同的光谱上的这种 behavior， 不同的光谱的曲线。这就像我们人的指纹，能够告诉我们这种物质它是什么。So by using spectral measurement, we can tell the materials, the objects, what are they? By using remote sensing, spectral remote sensing. So what do you see here? There is a spectrometer called Moon Meteorology Mapper M-Cube on board India's Chandrayaan-1 mission, this satellite. So this M-Cube spectrometer take images of the lunar surface, and then from the data we can generate this type of spectral curves, okay, for any place on the lunar surface. And then we compare the spectral curves with the pure white eyes spectral curve, which is this one, in the blue curve over here. Okay. The pure white eyes, the spectral curve will be like that one in blue. While we compare this white eyes spectral curve with others measured on the lunar surface. You can see the 3 red ones, they are measured in different places, at the lunar south pole or at the lunar north pole. They look like very similar to the water ice spectral curve, right? So this basically tells us, indeed, there are some water ice over there. The upper one in black, this is another example. No ice at all. We put there just for comparison purpose. So you can see, if it's not water ice, it will look like very differently with the water ice one in blue. So through spectral measurements, indeed, scientists identified water ice on the south pole and the north pole of the moon already. The third technique I would like to share with you is so-called neutron detector. This is a little bit more scientific, so I try to explain it in very general language. Okay, neutron detector, 中子探测器, which means why we can use neutron detector to identify water or hydrogen. Because neutrons, okay, they passing, when neutrons passing through regions, okay, with high hydrogen concentration, their speed will decrease significantly. 也就是说，当中子通过很多有氢元素的地方的时候，中子的速度会显著下降。中子来自于宇宙射线和月球表面的 interaction， 这样它会很多这样的这个中子在月球表面广泛存在。而如果有些地方中子它的速度显著低于别的地方，这就说明这些地方可能就有很多的氢的元素 ，lot of hydrogen might be there, and this velocity change of the hydrogen of the neutrons can be measured by equipment like this one, okay, called neutron detector, and in turn we can measure, we can identify places with hydrogen abundance, and hydrogen is actually an indication of water. Therefore, by using neutron detector, we can also measure a lot of places, and you see some of the polar regions, you see a lot of hydrogen over there. So there are potentially water ice existing there. While we have other techniques can also help to identify what are there, such as radar, okay, and ultraviolet spectrometer. I'm not going to talk about those in detail, but if you are interested in this, you may study remote sensing with us in Polytechnic University in the future. Okay? Well, as a lot of water discovered at the lunar polar regions, you know, what could be a resource to sustain life, right, on the moon? Water can also be energy to provide the fuels for rockets. So these important resources, very valuable. That's the reason a lot of countries in the world, they are planning to land robots to the South Pole or the North Pole to check the situation over there. So the first one will be this one, Chang'e 7. Chang'e 7 will be launched in August this year, 2026. Okay. While Chang'e 7 will include a lander, a rover, robotic vehicle, and there will also be a mini hopper. Okay, and this mini hopper can fly into those so-called permanently shadowed regions to have a detailed investigation to check if there is what else over there or not. The mini hopper carries a so-called watt molecular analyzer. Basically, it will heat some soil samples inside the regions and use the spectrometer to measure if there is what molecule over there or not. So this will be the very important and interesting, exciting mission to the lunar South Pole. This time, we go to the real lunar South Pole. Other countries landed recent years from India, from Japan, but they didn't reach the south part, okay, as much as the Chang'e 7 will go. Okay, you see, this is the south polar point, 90 degrees south. Okay, so Chang'e 7 will land very close to this place to have a detailed investigation of potential what else over there. And the United States, they also planned missions to the lunar South Pole. Next month, the Artemis 2 mission will be launched. The Artemis 2 will carry 4 astronauts from the United States, but they will only orbiting the moon, will not land. Okay. Until the Artemis 4 or 5, after 7 years, the Artemis 4 or 5 will bring several astronauts to the lunar surface, to the south pole of the moon, and to have an in situ investigation of potential water ice and other materials, other research over there. So the lunar South Pole will be very popular in the coming 10, 20 years. And potentially, we, China, together with other international community, will build a potential research station at the lunar South Pole in the future. Well, the robotic exploration to the moon is very important, and the very fundamental method to explore an unknown place, right? While robotics actually has been well developed, advanced in recent years, I believe some of you may already notice this type of robot, right? This is a very advanced robot from a company called Robot. You see, very powerful. Can jump, climb mountains, okay? Can even climb like 1 meter high obstacles, okay? Can walk on steps, even walk with 2 wheels. Okay. Travel on the slopes is very difficult for conventional rovers or vehicles, but for this type of robots, you see, it's very convenient for them to travel. So this company is a very famous one based in Hangzhou city. Another one I want to share with you. Very interesting, huh? It's playing Kung Fu. Okay. This is come from a company called Unitree. Okay. This robot with a body shaped like a human being, okay, with very flexible movement structure and control ability. So this advanced robotics technology have been very exciting and interesting only in recent several years. the question is, can this type of advanced robotics technology be directly used on the moon for lunar exploration? The answer is not that easy. Okay. I want to share with you, for example, if we want to deploy a robot on the lunar surface, compared with the situation on Earth, the two examples you have just seen, we have very different scenarios and important challenges over there. The first one, power. On the moon, especially if we go to the south pole of the moon, if we rely on solar power, then this will be a significant challenge. The solar powered robot, always they are ineffective. Okay, we need a much better energy storage or even nuclear power sources, while this is very difficult to achieve for conventional robot, right? The second constraint is thermal related, which means the temperatures on the lunar surface changes significantly from negative 200 degrees almost to up to 100, positive 150 degrees. So such a significant variation, changes of temperature from the lunar day to the lunar night, this requires very complex thermal management to protect the electronics. Number 3, radiation. You know, on the lunar surface, the radiation in space, in deep space, is very serious. So we need to protect the electronics so that they will not be damaged by cosmic radiation, while this requires spatial protection and materials. Number 4, the vacuum environment. You know, 月球没有大气层. It's a vacuum environment. Then, for the mechanical components, for the robotic electronics, we need a special design for the lubrication of the moving parts and, more importantly, cooling. Okay, the movement of the robot, the components, the computation unit, computers on board the robot. How can we 散热？没有大气，没有大气层。我们大家用电脑知道哈，在每一个电脑里头都有一个风扇，这个风扇转得很快，帮助你这个电脑去散热。但是在月球上 ，we don't have atmosphere. You cannot use a fan to help you to cool your computer, your components. So this will be a significant difficulty. And number 5, communication. There is some delay of communication, data transfer from the moon to Earth. We cannot control the robots in real time. So this requires high levels of automation. And number 6, navigation. We don't have GPS on the moon. 没有 GPS 月球上。Then we need so-called self-localization capability. 需要我的机器人能够自主，自己靠自己，我能够知道我在哪里，我要去哪里，我该怎么走。This is quite different, quite a challenge compared with the situation we apply the robotics on the Earth's surface. And the last one, but not the least, okay, weight and size constraints. Because you know the launch vehicle is always got some limitations. Okay. We requires the robot to be designed as small as possible, as light as possible. Okay. 你的机器人一定要又小巧 又轻，这样才能够这个被运到月球上面去。So all these difficulties makes the lunar robot very different with those robots you see on Earth applications. While in recent years, you see here a lot of concepts or some prototype designs already. They are designed to operate on the lunar surface. Some, they have a regular design with wheels, okay, 4 of them or 6 of them, wheels to travel, to move on the surface. Some very fantastic design, like balls, 一个球状的机器人they can just travel as very flexible on the lunar surface. They will 他们不会倒就算摔倒也不怕这种球形的机器人Some like these spiders, okay, 像蜘蛛一样的机器人 very flexible, can even enter some small caves, okay, to study. So a lot of researches, designs are going on. Well, I want to share with you what we are doing here in Hong Kong. So there is a mission called Channel 8, which will be launched around 2029, 3 or 4 years time from now. So Channel 8 will land at the lunar South Pole as well, okay, somewhere here. All right. And Channel 8 will be a much more complex, okay, mission. Involves, for example, landers, lunar vehicles, robots, and this so-called multifunctional tower. Okay, so this involves a lot of payloads, instruments, okay, facilities in this mission. So Channel 8 will, of course, try to search for interesting findings at the lunar South Pole, including potential water ice over there, and Channel 8 will test the technology of 3D printing on the lunar surface by collecting some soil samples, put in a sintering machine, okay, then print small bricks, try to test the technology of construction on the lunar surface. So this will be the Channel 8 mission in several years' time from now. While Hong Kong, okay, we are building a robot for the Channel 8 mission. So this is the announcement by the China National Administration, 中国国家航天局Last year in Shanghai, in 中国航天日国家航天局 announced the Hong Kong operational robot, okay, will be produced by us, by scientists in Hong Kong. Okay, so this one, okay, in response to the participation in this Channel 8 mission. So the government, Hong Kong government, they funded a center, okay, under the Inner Hong Kong funding scheme. So a number of universities, local universities, including Hong Kong UST, PolyU, and other universities, and mainland partners and the international partners. So we work together, try to build such a robot for the Channel 8 mission. And this is also mentioned by the chief executive in his policy address in both 2024 and 2025, mentioned twice in the policy address statement. So this Hong Kong operational robot, as you see from here, with a very interesting design. Okay, just like a ship sailing on the sea. Okay, this body looks like a ship, right? A ship, and here is the sail. Okay. And this robot will be four-wheeled, with 4 wheels to move around the lunar surface, and with 2 arms to operate, okay, to take instruments, deploy some scientific payloads, to collect some soil samples, etc. Okay, so we are working on this development of the robot, and I want to share with you a little bit, as some of you may participate in our computation, in our competition later on, submit your design, works for the robot. So see here, a robot on the moon, normally you need to consider, for example, several subsystems. The first one is called avionics subsystem, which basically is a computer, okay, to control all the programs, the movements of the robot. Okay. Then the second one is called structure subsystem. Basically, is responsible for this body here. It should be stable, okay, can hold, can protect other instruments. And the mechanism subsystem, okay, which is, for example, this mast here, this pillar, this mast here, hold the head and the hands of this robot, and some other cables, for example. The mobility subsystem, which is the wheels, okay, how it moves, control the turn of the wheels, okay. And the fifth one is called the operation subsystem, which is for these 2 arms. How to control the arms, the hands, to operate, okay, to manipulate some instruments, etc. Right? And there is so-called guidance, navigation, and control subsystem, GNC system. This is always a very important subsystem for any robotic vehicle or robots. Okay, you need to understand your position, your destination. How can you travel from there to there? Okay, how can you make the travel safe and smooth? So this GNC system is a very important one. Okay, and also power subsystem. Okay, so this sail not only look like a sail, not just for beautiful looking purpose. Okay, this is actually a solar panel. Okay, when the robot travel on the lunar surface, the sail will always facing the solar illumination, so that to charge this robot. Okay, and there is also a thermal control subsystem to cool the different components, okay, to provide thermal support to maintain the electronics to be functional. Okay, so this is the structure or the main design you need to consider if you want to propose a robotic platform to be functional on the lunar surface. Well, I want to share with you some work we are doing here at PolyU in my laboratory. So my team is responsible for the robot's eye vision system. Just like a human beings, we have eyes, right? So we can see the environment. We can feel the distance, the size information to help control our behavior. So the vision system we are developing here at PolyU is also act like this. While the different difference is here. We are developing a so-called enhanced vision system so that this robot can be operational on the lunar South Pole, okay, probably. You already noticed, right? The lunar South Pole, very low sound illumination angle, a lot of shadows in your views. If you look at the surface, the majority of your view will be in shadow. So if we using a regular vision system, then you will see things like this. Some places they are very bright, some places totally black in shadow. While what we are doing here, we are using AI to help us. So we put AI in the vision system of the robot so that we can see into the shadows like this one. Okay? So we call this type of technology enhanced vision system. Just like you wear a glass, you can see into the shadows. Okay? While I would say this would be the first AI system to be used in any outer space rover or robot exploration missions. Okay. This will come from Hong Kong. Another example I want to share with you, this one. We are using the two eyes, okay, vision system. We test the two eyes in our laboratory. So we let the vehicle move and take photographs of the environment, and then it will provide a real-time positioning and localization of the robot. This is very important on the lunar surface because we don't have GPS to help us anymore. We need to rely on our own eyes to feel the environment, to observe the surrounding situation so that to help us identify, to localize ourselves. So this is what we are doing in our laboratory. Well, of course, in other countries or the international community, people are thinking about other alternatives for robotic exploration on the lunar surface, such as this type of robotic dog you are seeing here. So in the next couple of years, China will also send astronauts to the lunar surface. Okay? And before the astronaut landing mission, potentially this type of robotic dogs might be sent to the lunar surface as well. Okay? So you can imagine, also they work very efficiently, very well on the Earth scenario. But if you go to the moon, the robotic dogs still we have a lot of work to do to make them functional on the lunar surface. And other more advanced, sophisticated robot, or we call them robotic vehicles, okay, such as these examples you see here, they will help astronauts to move, to travel on the lunar surface in the future. Okay, so China, they are developing, okay, this type of manned lunar vehicles. Other countries such as Japan, United States, they are developing theirs as well. So PolyU, we also are involved in the manned lunar vehicle development as well. So this opens a lot of opportunities for future study, future exploration. So students, if you are interested in robotics, you will see a lot of chances, exciting developments over there. And finally, I want to share with you some future prospects in terms of lunar exploration, in terms of space exploration. So let's come back to this figure of the solar system you see here. So this is the moon. We are here on Earth. The lunar exploration missions, they are going on, such as the Channel 7, Channel 8 missions from China, the Artemis missions from the United States, and the missions from Russia, from Europe, from Japan, etc. So in about 20 to 30 years of time, we will be able to this type of lunar habitation facilities on the moon. Okay. So with our eyes, in about 30 years, maximum 50 years of time, we will be able to see these scenarios on the lunar surface. And if we move further, we go to the Mars, like this one here. Elon Musk is going to send astronauts to Mars, right? To build bases on Mars. So maybe in 50 to 80 years of time, people live on the Martian surface. Could be true. Okay. I believe in my time, we will be able to see this happen. People live on Mars. Okay. I believe you will also have the chance to see this as well. Then, if we go further, we go to the Jupiter system. This is the Jupiter, several moons of the Jupiter. There is a very interesting moon of the Jupiter system, which is called Europa. Why this Europa, the second moon of Jupiter, is interesting? Because this Europa is a large ice moon. The surface is an ice sheet. Below the ice sheet, there is an ocean over there. And the Cassini spacecraft traveled by the Jupiter system and observed there are some floating eruptions from the surface of Europa. This means there must be some heat energy or volcanic activities below the ocean surface, below the ice sheet in Europa. So you can imagine, right? There is water over there. There is heat, volcanic activities. With water and heat, there could be life. Right? So the United States sent a mission called Europa Clipper 2 years ago to visit the Jupiter system. And the Europe Space Agency also sent a mission called JUICE to explore the Jupiter system, also 2 years ago. So in about 4 years' time, by 2030, the Europa Clipper from US and the JUICE mission from Europe, they will arrive the Jupiter system. And they will have a detailed, more sensing investigation of the Europa to see what's going on over there. So in about 4 years or 5 years' time, we will know more secrets from this Europa in the Jupiter system. While if we want to send robot or astronauts to the surface of Europa, I would believe this requires much longer time. Okay, maybe in 80 or 100 years. Okay, because there is a very serious radiation zone between Mars and Jupiter, which is very dangerous for astronauts to travel over there. Okay, so we need to overcome this difficulty in order to send astronauts to the Jupiter system. And if we move further, we go to the Saturn system. There is a famous moon called Titan. of Saturn. Okay, Titan is the only moon in the solar system with its own atmosphere. Okay, with the size Saturn similar to our Earth, and with atmosphere and water. Also, we don't know it's water or some other liquid yet, but there are liquid materials flow on the surface of Titan. So this very much look similar to our Earth. Then people would ask, is there any life over there? This will be a future interesting target for exploration. And Saturn also got another important or interesting moon called Enceladus. Enceladus, okay, very similar to the Europa, is also an ice moon with an ice shear. Below the ice shear, there is an ocean. And the Cassini spacecraft, this is a real photograph taken by the camera on board the Cassini spacecraft 20 years ago. So the Cassini camera noticed this type of plants, okay, or curtain eruptions from the south polar region of the Enceladus. So you can imagine, in order to have this type of eruption, there must be some heat energy or activities or volcanic eruption below the sea, below the ice shear of Enceladus. So there is water there, there is heat, volcanic activities. Then there could be life. So as you can imagine, in our solar system already a lot of interesting places to visit. So maybe in 100 years later or 200 years later, we will be able to visit these places one by one and discover anything, any potential life over there. So eventually, okay, after 500 years, 1,000 years, eventually, someday, we human beings, we will be able to travel outside our solar system. We enter the magnificent Milky Way galaxy. And after maybe 5,000 years, 10,000 years, the technology, they will evolve in an exponent function, not linearly. So someday in the future, eventually, we will be able to travel outside our galaxy. We visit other galaxies. We enter the magnificent universe. So this is the meaning of space exploration. This is also the value of exploration. We explore other worlds, but keep in mind, understanding our own and create the future. This will realize you, young fellows, teachers, okay, students. We work together to make this happen. So with this, I conclude my talk. Thank you very much.